Here's how to factor a difference of squares. Recall that a difference of squares is two terms that are perfect squares that are subtracted from each other. So a squared minus b squared is a difference of squares, and that factors into a plus b times a minus b. Let's take a look at some examples. Our first example is x squared minus 81. The first thing we want to do is figure out, is this indeed a difference of squares? Well, it is a difference because I have a subtraction in the middle, and x squared actually factors into x times x, so that x squared is a perfect square. 81 factors into 9 times 9, so that is a perfect square, so I do indeed have a difference of squares. So I'm going to take the x, take the 9, and put them into parentheses, one with a plus and one with a minus, and that's my final answer. If you wanted to check this, you would FOIL it, and when you do, you find out that you do indeed get x squared minus 81. Second example is 16x squared minus 9y squared. And again, this does look like a difference of squares because 16x squared is 4x and a 4x, and 9y squared is a 3y and a 3y. So I'll take the 4x and the 3y, put them into parentheses, one with a plus and one with a minus. So 16x squared minus 9y squared factors into 4x plus 3y times 4x minus 3y. And my last example here does not look like a difference of squares because I know that 3 is not a perfect square, nor is 3 cubed, nor is 27, nor is x. But the first thing I do notice is that I can actually factor a 3 and an x out of each term here. So let's go ahead and do that. So factor out a greatest common factor of 3x, and that's going to leave me with x squared minus 9. And x squared minus 9 is indeed a difference of squares because x squared is x times x. 3 is 9 times 9. So I'll take my x and my 3. Don't forget the 3x that was out front that I factored out as a greatest common factor. And then I'll have an x plus 3 and an x minus 3. And remember, for any of these, you can check by FOILing and multiplying to see if you get back to where you